Hey everyone, welcome back to TechBit Academy. Please like this video and subscribe to the channel.
Welcome to The Explainer. I'm absolutely thrilled you're here today because we're going to be looking at something completely invisible, yet it literally powers practically every single digital interaction you have. Think about it. Just loading this explainer, that just triggered dozens of servers spread across multiple continents, all talking to each other in absolute milliseconds. Today, we're decoding that grand tech illusion by taking a look inside the architecture of distributed systems. So if you're the kind of learner who loves getting into the nitty-gritty, the structured technical reality hidden right behind your screens, well, you're in the exact right place. Let's dive right in. So, is the system you're using right now actually an illusion? Seriously, think about the device you're watching this on for a second. You click a link and boom, a page loads instantly. It feels like just one solid machine doing all the heavy lifting, right? Like this perfectly unified piece of technology. But here's the crazy part. That seamless, perfectly smooth experience, it's actually a carefully orchestrated piece of technological sleight of hand. It's magic. We're so incredibly used to the instantaneous response of our apps and platforms that we rarely stop to consider the sheer volume of independent actors required to fetch, render, and deliver that data right to our screens in real time. Because behind the glass of your screen, there's this entire backstage reality. It's a massive, complex maze of physical servers bound together by literally millions of lines of code. Whenever you interact with your device, you aren't just tapping glass. You're actually triggering a sprawling, highly choreographed network of independent machines working furiously in the shadows. It's this crucial overlap between the physical hardware, the cold, hard server racks sitting in data centers all over the world, and the super intricate software instructions that bind them all together. You're not just communicating with one computer anymore. No way. You're interacting with a globally distributed framework that is specifically designed to never ever let you see the seams. Formally speaking, a distributed system is defined by its ability to take all these independent computers and present them as a single, coherent whole. And the absolute key word here is appears. The system takes the incredibly messy, super complex reality of multiple separate computers, complete with their own random hardware quirks, network latency, and, of course, potential points of failure, and it just hides it all. How? Well, it achieves this primarily through a crucial software layer that we often call middleware. This middleware kind of acts as the great deceiver. It sits right there between the applications and the operating systems, managing all the chaotic communication and presenting you, the user, with a perfectly smooth, unified front. It's deception for sure, but it is an entirely necessary deception. Now, there's a massive, inherent paradox here. Autonomous computers on one side versus a single coherent system on the other. So how do we bridge that massive gap? Because these autonomous machines are highly independent. They operate entirely on their own internal clocks, yet they have to work incredibly hard to maintain this unified facade. Computer scientist Leslie Lampard actually captured the reality of this paradox perfectly with a famous joke. He said, "A distributed system is one in which the failure of a computer you didn't even know existed can render your own computer unusable." I mean, that really hits the nail on the head, doesn't it? They're doing all the heavy lifting in the background so that you never have to worry about which specific node is handling your request. But to the network itself, it's this highly volatile ballet of independent actors just constantly trying to stay in sync. To actually maintain this illusion, collaboration is completely non-negotiable. Because users, and hey, keep in mind that means both people like you and me, as well as other software programs, they believe they're dealing with just one system. So these autonomous components are absolutely forced to collaborate. And let me tell you, this collaboration is incredibly difficult. These machines have to constantly pass messages back and forth, synchronize their clocks, and handle inevitable network delays without the user ever even noticing a hiccup. If they don't work together with absolute fault-tolerant precision, the whole illusion shatters. Flawless, invisible teamwork is literally the absolute requirement for this architecture to even survive. Ultimately, you have to ask, why engineer all this crazy complexity in the first place? Well, the main goal of a distributed system is to make it easy for users to access remote resources and to share them in a controlled and efficient way. That right there is the fundamental why behind the entire architecture. This incredibly complex teamwork exists solely to make our lives and the lives of our applications scalable and resilient. It takes all these remote, complicated resources and just makes them effortlessly accessible. And I really want to emphasize those words, controlled and efficient. This is the entire crux of distributed architecture. Think about it. Without efficiency, the system drags and latency spikes. But without control, it just collapses into utter chaos. So, what exactly are we sharing across all these networks? Well, we aren't just talking about sharing a dusty old networked office printer anymore. We're talking about globally distributed storage facilities, massive data lakes, and highly complex web applications. Just think about the sheer scale and variety of the infrastructure handling your own daily workflow. Anytime you push code to a remote repository, query a massive database, or even just stream content from a CDN, you're actively leveraging this vast, distributed architecture. All these everyday actions completely rely on that invisible, lightning-fast collaboration to just function at scale, completely without a hitch. So the next time you open a web page, I want you to ask yourself, how many autonomous computers are collaborating right this exact second to make it look so effortless? I challenge you to look past the glass of that single screen right in front of you. Take just a moment to appreciate the massive, unseen collaboration that's working tirelessly in the background, handling failures, routing traffic, and syncing data, all just to make your entire digital life possible. Thanks so much for joining me on this explainer, and hey, keep questioning those incredible systems operating just out of sight.